All right. So, good day, everyone. You are welcome to today's session. Now, in today's lesson, we have a question before us, and we would like to solve it. Now, the question says that prove that if F1 and F2 are sigma algebras of subset of X, and F3 is the intersection of F1 and F2, then F3 is a sigma algebra. So, in this question, we are supposed to prove that F3, which is the intersection of F1 and F2, is a sigma algebra if F1 and F2 are sigma algebras. That is what we want to prove. Before we start the proof, we want to write that, in fact, we are given that from the question, we are given that F1 and then F2 are sigma algebras. We know that from the question, right? We know this. And then we also know that F3 is actually F1 intersection F2, right? So we know this from the question. Both F1 and F2 are sigma algebras, and F3 is the intersection of F1 and then F2. That means that F3 consists all of the sets that are in both F1 and then F2. Now we need to show that F3 satisfies the three properties of sigma algebra, right? So we need to show that F3 satisfies the three properties of sigma algebra before we can conclude that F3 is a sigma algebra. So the first property we need to show that the universal set X belongs to F3. We need to show this. This is the first property for sigma algebras. We need to show that the universal set X belongs to F3. Now, we know that F1, in fact, since F1 and F2, we know this from the question. Since F1 and F2 are sigma algebras, both are sigma algebras, then it means that X is contained or belongs to both F1, right, and then F2. So X is contained or belongs to F1 and then F2. Because F1 and F2 are sigma algebras. That means that both of them contain what? X. And if both of them contain X, then what it means is that X belongs to the intersection of these two sets. Right? The intersection of F1 and F2. That means that X, which is the universal set, belongs to the intersection of F1 and then F2. Of course, we know that F3 is the intersection of F1 and F2. So if the universal set X belongs to the intersection of these two sets, then we can boldly say that X, which is the universal set, belongs to what? F3. Now the next thing is we need to show for the second property. And the second property is the closure and the complement. Is the closure and the complement. Now what we need to do here is that suppose that if we have maybe a set A which belongs to F3, then we know that, in fact, let's first state what the property is about. The property says that if I pick any set, let's say A, which belongs to a set of sigma algebras, let's say it belongs to F1 and F2, then we know that A complement is also in F1 and then F2. So this is what the property says. So now if A is in F3, then it means that A belongs to F1 and A is also in, or is contained in F2, because F3 is actually the intersection of F1 and F2. So if you are saying that A belongs to F3, then it means that we can find A in F1 and we can also find A in F2. That is what it means. This is because both F1 and then F2 are sigma algebras. This holds because both F1 and then F2 are sigma algebras. Now we need to show that they are closed under the complement, right? So since we are saying that F1 and F2 are sigma algebras, then it means that A complement belongs to F1, and the same A complement also belongs to what? F2. This is because we are saying that F1 and F2 are sigma algebras. So if A is in F1 and the same A, the set A, is also in F2, and both F1 and F2 are sigma algebras, then what it means is that the complement of A also belongs to both sets, which is F1 and then F2. Now this implies that the A complement belongs to F1 intersection F2. Right. If you are saying that A complement belongs to F1 and the same A complement belongs to F2, then we can imply that A complement is found in F1 intersection F2. And if this holds, then we can boldly say that A complement belongs to F3. So we have been able to show that if A is in F3, then its complement, which is A complement, is also in F3. Now the last property we need to show is what we call closure under countable union. Closure under countable unions. Now what does that one say? That one says that if you have any sequence, let's say if you have any sequence AN which maybe belongs to a sigma algebra, any set which is a sigma algebra, let's say F1 and then F2. If we have this, then what it means that if this belongs to F1, if the sequence AN belongs to F1 and F2, then we can say that the union from n equals 1 to infinity of AN belongs to what? F1 and then F2. That is what the property says. If AN is a sequence of set which belongs to a sigma algebra F1 and F2, then the union of AN, the union of those sequences from n equals 1 to infinity also belongs to F1 and then F2. And we need to show this. So now we say that let the sequence AN, let AN be a sequence of set in F3. Let sequence of set in F3. This is what we are saying. Now, if AN, the sequence AN belongs to F3, then what we are trying to say is that it follows that AN is in F1 and the same AN is also in what? F2. This is because F3 is the intersection of F1 and F2. Right? So if you are saying that AN, which is a sequence of set, belongs to F3, then it implies or it follows that AN is found in F1 and it is also found in what? F2. Now, since we know that F1 and then F2 are sigma algebras, now we know this, that F1 and F2 are sigma algebras. What it means is that the union from n equals 1 to infinity of AN belongs to F1, right? Because F1 is a sigma algebra and the union from n equals 1 to infinity of AN also belongs to what? F2. This is because we know that F1 and then F2 are sigma algebras. So we can confidently say that the union of the sequence belongs to F1 and the same union of the sequence belongs to what? F2. Therefore, we can say that the union from n equals 1 to infinity of AN belongs to F1 intersection F2, of which this is equal to F3, right? Because F1 intersection F2 is F3. So we have been able to show that if you have a sequence of set AN which belongs to F3, then the union from n equals 1 to infinity of AN of these sequences of set also belongs to F3. Now, since what this means is that since all three properties hold, we can confidently conclude that F3 is a sigma algebra. We can confidently conclude that F3 is a sigma algebra. So this is the proof to this particular question. Have a nice day.